All right, section 5.1. We're going to be proving identities, so prove it. We want to find some identities on your salmon sheet of paper. Your cosecant theta. Your cosecant theta is equal to 1 over sine theta. We'll be using all, and then secant theta over cosine, cotangent over tangent, or cotangent is equal to 1 over tangent theta. We're going to be using all of the reciprocal identities and then also the ratio identities and also your Pythagorean identities. So keep that salmon sheet out so you have it with, or you have access to it at all times throughout this unit. Okay, let's get started. Okay, prove each of the following. Okay, sine theta, cotangent theta, cosine theta. Anytime I'm proving any identity, one thing I want to look for is which side do I have more? What do I know? Okay, so looking at number 1, I have sine theta, cotangent theta. Well, I know sine theta and cotangent theta are, well, sine theta, you can kind of leave that. We want to look at cotangent theta and think about what is that? What is cotangent theta? Well, we know cotangent theta is equal to cosine theta over sine theta. Okay, so now let's begin. We know we're going to leave sine theta because it's already in sine cosine. Then cotangent theta, we're going to change to cosine theta over sine theta. Okay, so now let's think about this. Okay, we have, this is sine over 1, and they're multiplying. So now, if we multiply sine through, we have sine theta times cosine theta over sine theta, which your sines divide to 1. So you're going to have cosine theta, which is equal to cosine theta. Oh, that was a fun one to start out with. Okay, now we're looking at secant and cotangent. Okay, so, or cosecant. Well, I have more with secant and cotangent, so I'm going to work with that side. What is secant? Well, secant is 1 over cosine theta. That's a great looking cosine. I'm glad I wrote it like that. That way everybody's like, what was that? Okay, so cosine theta is equal to secant, and cotangent, like I said before, is cosine over sine. So I'm going to write, okay, secant is 1 over cosine theta, and now my cotangent I'm going to write as cosine theta over sine theta. This one's very similar to question 1. Okay, so now when I multiply through, I get cosine theta over cosine theta times sine theta. Well, your cosine thetas turn out to be 1 when you divide them out. So we have 1 over sine theta, which is equal to cosecant theta, which is equal to cosecant theta. Okay? Good way to start off. We're moving right along now. Okay, then the next one. Ooh, we have 3 different things we're looking at here. Okay, so the first thing we want to kind of look at is what do we have the most of, or what can we kind of maneuver around to get rid of something so we can make our smaller thing. So this section is larger, correct? And we want to break that down so it turns into tangent theta, cosine theta. Well, we know that we have a secant and a cotangent. Well, I want to change those so they're in sine and cosine. So I'm going to make this sine theta times secant theta is 1 over cosine theta. And like I said before, cotangent theta is equal to cosine theta over sine theta. Well, I'm going to put each one of these functions into my equation. So I have 1 over cosine theta plus cosine theta over sine theta. Okay, now you should be asking yourself, okay, I just did that. Now what can I do to make it kind of cosine or tangent? Well, I know tangent theta is sine over cosine. Well, my first term here, I already have the cosine. I just need to multiply my sine through. So I'm going to go sine theta over cosine theta plus sine theta times cosine theta over sine theta. Which now we look at it and we say, oh, I have tangent right here. So I'm good with tangent. Now let's look at this term. Well, all right, tangent theta plus, okay, I have sine divided by sine, or sine times cosine divided by sine. Well, from before, we found out that the sines divide to be 1, so we just have cosine left. Okay? And as you can see, this is the same as that. Okay? Still on. Oh, look at this one. Okay, now we need to look at this term. This term is it has more to it. It's a larger amount of materials. So we know that we have sine, secant, and cosecant. Well, secant theta is equal to 1 over cosine theta. And cosecant theta is equal to 1 over sine theta. Okay, so those are important things. We want to change everything so it's in terms of sine and cosine. Because we know that tangent is sine theta over cosine theta. Okay. So, first off, I'm going to keep my sine theta. And now I want to change my secant and my cosecant into sine and cosine. So we have 1 over cosine theta plus 1 over, or divided by sine theta. Okay. So now we have sine times 1 over cosine theta, the quantity 1 over cosine theta plus sine theta. Okay, so now we can once again distribute our sine. So now we're going to have sine theta over cosine theta plus sine theta over sine theta. Well, we know that sine theta, this term right here, sine theta over cosine theta, is tangent. Okay, so we're going to put tangent theta. That's done. Now we know that sine theta divided by sine theta is 1, which is equal to our original term. Okay. Now, getting a little trickier here. We're not just working with a plain old cosine or sine anymore. Now we have quads and squares. Or, yeah, quad here and quad here. So 4 sines and 4 cosines. Well, ask yourself, okay, cosine to the 4th minus sine to the 4th. I have the difference of squares right there. So I'm going to separate those out right away. Once again, we're working with the side with the most on it. Okay, so cosine, remember the difference of squares? Squared theta minus sine squared theta times cosine squared theta plus sine squared theta. All right, so, and then we're going to put that all under, or all over cosine squared. Cosine squared theta. That's kind of ugly, but work with me. Okay. I guess I'm writing Z's now too. I'm trying to spell words with Z's here. Now, okay. I know that cosine squared plus sine squared is equal to 1. Okay. So I'm going to rewrite my expression as cosine squared theta minus sine squared theta all over cosine squared theta. Because since that's 1 times anything, well, that's the multiplicative identity, so we know that that's going to stay the same. All right? So now we're trying to get a 1 and a candidate squared. So I see I have a negative sign right between my cosine squared and sine squared. Well, I can separate my cosines out, and my sine cosine out. Okay? So I have cosine squared theta over cosine squared theta minus, remember we're going to keep our sign. Kind of hard to see in there, but there's a minus in there. Okay, so minus sine squared theta over cosine squared theta. So now I have 1 minus, this turns into tangent squared theta, which is what we're looking for right there. Kind of like a half heart going on. The other half, I don't know where it went. You could say it's somewhere in here. I feel like John Madden writing on the board today. Okay. Now the next one. Number 6, and it'll let me change it. Okay. Once again, oh, we got a lot going on. So I'm gonna move this question up right here. Move this up a little bit. Okay, so once again we have a sine to the 4th and then cosine to the 4th. But we also have a sine squared theta times cosine theta in your numerator. Well, it's a 10. Okay, so I have this and this. Well, I know that there's more in this half of, on the half of the equal sign, okay? So I'm gonna work with that side. Well, once again, from before, we know that we have the difference of squares. So sine squared theta minus cosine squared theta. And that's gonna multiply by sine squared theta plus sine squared theta. Oh. I mean cosine. See? Cosine squared theta. Okay. Now my denominator stays the same. Cosine squared theta or cosine squared theta. There's a lot going on there, okay? Now, we know that this term by our identity is 1. Okay, so I'm going to rewrite everything since I know that's 1. My multiplicative identity, so that's going to be sine theta minus cosine squared theta, all over sine squared theta cosine squared theta. Now, since I have a minus sign in my numerator, right here, I can separate those two terms. So now I'm going to have sine theta, feel orangey for this question, so I'm using orange here, over sine squared theta times cosine squared theta. Okay, and then minus, remember we have the minus sign, So cosine squared theta over sine squared theta and cosine squared theta. Well, from earlier we know that sine divided by sine times cosine is equal to just your cosine. Well, we have squares here, same situation. These two are going to become 1, or divide to become 1, not those two. So we're going to those become 1. So it'll be like 1 over 1. So now I have 1 over cosine squared theta minus 1 over sine squared theta. And now you should be thinking, okay, is that what I want? Am I where I want to be? I need a secant squared theta and a cosecant squared theta. Well, looking here, we know that those are going to be the inverses of cosine squared theta and sine squared theta, which I have both of those right here. Okay, so 1 over cosine squared theta is is secant squared theta. Squared theta minus cosecant squared theta, which is what we're looking for up here. Okay. Now smile with me, stick with me a little bit here. We only have this one more left. So let's truck through this and then we can get started on the homework or do whatever you would like to do. Well, okay, here I have tangent theta plus cotangent theta equals secant cosecant theta. Okay. Now I always ask myself, which side has more on it? Well, they both have 2 terms. So I'm going to basically look at, okay, I want to deal with the side where we're adding. Because I know that I have a sine cosine here and a sine cosine here, and I should get to 1 over cosine theta and then 1 over sine theta. I know I need to get to that. So it's kind of like you're looking where you're going, but you need to figure out how you're going to get there. You're dealing with the maze here. Okay, so we know that tangent theta is sine theta over cosine theta. So now I'm going to do cotangent, which is cosine theta over sine theta. Question, can we add those two? I hope you're saying no, because our denominators are not the same. Cosine is not sine. Okay, so what do I need to do to get common denominators? Well, multiply sine theta. So we're multiplying by 1 on that side and multiplying 1 on this side. So we're not really changing the equation, we're just multiplying by 1. So we get common denominators. something we've been doing since like 3rd grade or something like that. So now we have sine theta times sine theta over cosine theta plus cosine, oh, I forgot the sine theta. So I have cosine theta times cosine theta all over sine theta times cosine theta. Okay, now you're thinking, okay, we're getting bigger, we're not getting smaller here. That's okay. Remember, now that we have common denominators we can add. Well, we know that a sine times a sine makes a sine squared. So we have sine squared theta plus cosine times cosine is cosine squared theta. And since we have common denominators, we can put that all over sine theta cosine theta times cosine. Sorry. Okay, well, you should be asking yourself, something looks similar here that we've done before. Well, that's right. We've found this is 1. So now I'm going to write it as 1 over sine theta times cosine theta is equal to 1, you can say 1 over sine theta times 1 over cosecant theta. Okay, or not cosecant. Somebody whispering in my ear cosecant there, I don't know who it was. Okay, so sine theta over cosine theta. Well, let's think about this. What did we want? We wanted secant over cosecant. Don't we have it now? We have 1 over sine theta, which is actually secant theta, and 1 over cosine theta, which is, oh, sorry, my bad. Right, I'm thinking ahead. So, which is actually cosecant theta times secant theta. And is that what we want? Let's take a look. Secant over cosine. They're not the same thing. So what we can do, because multiplication is, what's that word? Commutative. We can, then I write the word. Then we can change where they're located. So I'm going to put, then I'm erasing stuff off the pen. So it's going to be secant theta times cosecant theta. And that is what we want. Boom. Okay? Now, there's your summary. In class, we'll prove this one together. If you have any questions, let's do some work, get some work done, and have some fun. Have a good day.